So in 1.6, we are determining if functions are even or odd. And we're going to look at these both like graphically in a table at first, and then we will talk about how do we determine if they're even or odd algebraically. So a function is even if it's symmetric with respect to the y-axis. So remember, symmetrical means the same like on both sides. So our y-axis, our vertical axis, the left side and the right side look exactly the same. They're mirror images of each other. So when your left and right side are mirror images of each other, that's how you know that it is even. Also, you'll notice with this function, the end behavior matches on the left and right side. That will always be true. If the function is even, both end behaviors are going to be going towards positive infinity, or both end behaviors are going towards negative infinity. So if the end behavior is the same on the left and the right side, that also lets you know that that function is even, okay? So when we are talking about it in aspects of ordered pairs, if a function is even, that means that for every xy point on the graph, there's also a negative xy on the graph. So the x values, the x coordinates would be opposites, but the y coordinates will be the same. So you'll have x coordinates that are opposites. But same y coordinate. So your x coordinates are opposites, but your y coordinates will be the same. And that's just because of this like mirror image points, right? If this is the point 3, 0, this is the point negative 3, 0. So they're equal distance from that y-axis because they're symmetric. So all these x values are the same, or the x values are opposites, but their y values are the same. Okay? You can tell a function is odd if it is symmetric with respect to the origin. So now instead of folding it in half along the y-axis, you would fold it on this origin point, and then you would notice that the two sides would be the same. So they're symmetric with respect to the origin. So if we're looking at these coordinate points, what this means is that on these graphs, for every xy coordinate, there's a negative x, negative y. So both coordinates, x and y coordinates, will be opposites if it is an odd function, okay? So the x and y coordinates will be opposites if it's odd. Also, just like we talked about how on an even function, this end behavior is finishing in the same direction. Well, if it's odd, you'll notice like the right side finished towards positive infinity, the left side finished towards negative infinity. So that's also what will always be like a telltale. If the end behaviors are in opposite directions, that's how you know it's odd, okay? So then pretty easy here, if we look at these two graphs, we look at graph number 1. The left side is finishing towards positive infinity. The right side is finishing towards negative infinity. It is symmetric around this point, which means this graph would be an odd function. And then if you look at that parabola that's opening down in number 2, well, now both of our end behaviors are going towards negative infinity, and it is symmetrical along the y-axis. So if I were to fold this along this line, the left and the right side would sit on top of each other. They're mirror images. So because of that, that's how we know that this function is even. Then below that, I gave you two tables. So this is really when you just want to think about how these ordered pairs are related. So if you look at the points that they gave you in this first XY table, we have -10 and -50, -6 and -18, Then there's a point on the origin at 0, 0. And then I have 6, 18, and 10, 50. So what do you notice about these points? The x and the y coordinates are opposites. So if I have a negative 10 and a negative 50, I also have a positive 10 and a positive 50. So if my coordinates are complete opposites, that tells me that this function would be odd. If the x and the y coordinates are opposites, it's odd. Versus if I look at the table in number 4, I have negative 2, 14, negative 1, 5, 0, 2, and then a positive 1, 5, and a positive 2, 14. This is even because why? So the x's are opposites, but the y's are the same. Again, creating those mirror image points. Negative 2 up to 14, but then also positive 2 up to 14. So we have those mirror image points on each side of the y-axis. Okay? All right. So hopefully that's pretty easy to tell the symmetry or to look at those ordered pairs and know whether it's even or odd. The next thing we're going to look at is how do we check this algebraically. So a function is even if f of negative x equals f of x, meaning when I plug in a negative x value, I get the same y. That's what we said even functions were. They have the opposite x's but the same y. So if I plug in a negative x, the output is going to be the same as it was when I plugged in a positive x. Our function is going to be odd if when I plug in a negative x, so when my input is a negative x, my output is the opposite output as it was originally. So now I have that opposite y. So now if both of my coordinates are opposites, then that's how I know that the function is odd. Okay? All right. So we've got 3 here that we're going to practice and a typo. So we're determining whether the function is even, not off, but odd. Apologize for that, or neither. So our original function f of x is equal to 3x to the 4th minus 2x squared plus 5. So what we're going to do to check this is we're going to plug in a negative x. We are plugging in negative x for our x's. And if our output value is the same thing, then we're going to have an even function. If our output value is the opposite of what we have right here, then we're going to have odd. If it's not the same or the complete opposite, then it's going to be neither. So when we plug in negative x, this becomes 3 times negative x to the 4th minus 2 times negative x squared plus 5. What's going to happen if I raise a negative value to the 4th power? If I do a negative times a negative times a negative times a negative, I'm going to get a positive. So this is going to become 3x to the 4th because it's going to become positive. So it's the same thing as the positive x to the 4th. What happens if I square a negative? A negative times a negative becomes a positive. So, and when I multiply it by a negative 2, that would stay a negative 2x squared. And then obviously plus 5. So what does that mean? It is an even function because when I plugged in negative x, I got the same exact output. So f of negative x equaled the same thing as f of positive x. So if they equal the same thing, it's an even function. All right? So now let's look at number 6. F of x here is negative x to the 3rd power plus x squared plus 1. So we're going to plug in a negative x and see what happens. So we have then like a negative 1 basically times negative x to the 3rd plus negative x squared plus 1. So what happens when we cube a negative number? A negative times a negative times a negative is a negative. But then I multiply it by this negative. So all of a sudden I have a positive x to the third power. What happens when I square a negative? It becomes a positive, so plus x squared plus 1. Now, these became opposites the first term, but did the second term become opposites? No. They're not the same. They're not opposites, so this one is neither. All right, so then our last example here, number 7, we have f of x equals 6x to the third power minus 2x. So when we plug in negative x, we would have 6 times negative x to the third power minus 2 times negative x. We already talked about this, but when I cube negative x, that's going to give me a negative times the 6 would be a negative 6x to the third power. And then this negative x times this negative 2 would be a positive 2x. Why is this one odd? We have the opposite output, right? This was a positive, this is negative, this was a negative, this is positive. So when we plugged in a negative x, we got a negative y. Everything became opposite for our output value. So because the opposite x gave us an opposite y, it's an odd function. Okay?